Awesome. Yeah, so excited to hear from three presenters on from the connectivity working group. These are all going to be focused generally on demand response and load shifting via heat pump water heaters. They're all three experts. Two of them, Tristan DeFrontville and Jackson Wang, are manufacturers of UCMs, which help heat pump water heaters be connected even very remotely and be able to comply with signals. And then we also have Lily Buchler from Stanford, who's doing some really awesome testing on advanced heat pump water heater controls and kind of looking ahead for what that advanced testing can mean and what potentially can unlock. So with that, I'm going to turn it over to Tristan from SkyCentrics.
Great. Thank you so much, Noah. So everybody knows that am I sharing my screen?
You can. I'm sharing my screen. If you want to take control, you can.
Yeah. So okay. Well, I'm
or,
going to try. All right, great.
Or else I'll drive.
So, yeah, I know. I got it. So everybody knows that I have a lot of information on the slides. I'm going to take it for the team, cut my presentation in half. So everybody knows how this is an argument against time of use, right? So you can see on the weekdays of August on the California.
So sorry. The confusing thing on Teams is you can drive your slides, but you're not driving it for everybody. You have to press the button on the top that says "Take Control." Do you see that at the top of your screen?
Yeah, I do.
There you go. Now you got it.
Awesome. There we go. Perfect.
All right. Sorry about that. So, all right. This says weekdays in August and time of use. You can see the valley that you want to fill with the heat pump water heaters and the peak even change. So that's the idea there. Okay, I'm just going to skip through the next slides. You've seen them before. They show how water heaters, that orange is heat pump water heater load being able to shift. Commercial is even more exciting. Because we started off with Bonneville, I thought it was super interesting to look at their market transformation and why they made Washington and Oregon mandate a CTA 2045 port in every water heater. So you can see that there's 200,000 water heaters per year on this line here, starting in 2023. I thought it was 140,000, so that was cool to note. And then by 2031, they want 400,000 enrolled customers, which would be 50 resource megawatts, which is a regional benefit of $230 million. And then it says, and then there's 15 years of operation. Well, what's really cool about a cellular module is you can lift up that cellular module and put it on the next water heater with an EcoPort and get another 15 years. If you don't have that cellular module, for example, and you only have Wi-Fi and a new homeowner comes in or a new water heater comes in, somebody has to put it on Wi-Fi. So that's one of the fun potential benefits of a cellular module. So here, these are the standards and that have been sort of floating in the market, and OpenADR, EcoPort, and Title 24 JA13. So briefly, Title 24 JA13, it was made to have a battery and a schedule, and the battery is supposed to last 3 months, and it's only for new home construction right now. So what happens if the new home is powered off and not sold for 4 months? There's a chance the battery runs out, and that water heater schedule will be actually going on at the wrong time forever and every time in the future that the power goes out. OpenADR is expensive per device, but can be added to the module if necessary, whereas an EcoPort module gives you more choice in communication paths, whether it's cellular or wired or Wi-Fi, more competitive pathways to the device. So to keep costs down, there's competition. It future-proofs it because, as you can say, you can lift the module up or you can swap out the module by mailing people a no module, and there's no stranded assets because it always works to those water heaters. So this is the QPL. OpenADR is gracefully hosting the EcoPort qualified product list. So that's exciting because it removes some of the confusion. These are some of the things beyond water heaters that are in CTA 2045. Some have load shifting, others have load shaping capability. This is why garden style apartments and high-rise apartments and multifamily the sweet spot because commercial loads are much bigger. Central systems is exciting, and everybody should know that a major commercial association said that hey, we're going to start mandating a CTA 2045 port. It's a voluntary specification, but we're excited to have commercial water heating loads because that domestic water heater profile is so exciting. So I'm here on this last slide because this is the critical one. And I made a mistake. These first 3 bullets on the top left are about comparing an OEM cloud and typically the Wi-Fi they have to the EcoPort. I've already talked about the EcoPort and how it provides more choice. Briefly, the OEM cloud and Wi-Fi means you only have one path, Wi-Fi usually chosen, and only one cloud. And if there's 30 different water heaters, and it's amazing how many heat pump water heaters are coming to America, then you need a different contract versus having a contract with one module maker. You can hear my bias. I agree. And then every OEM has a different REST API instead of just one connection. Now, the other part here, the lower 3 bullets are critical. Nia and Dr. Bass of Oregon State University are going to release the results of their first purchasing of machines in retail off the shelf. So the machines were initially shipped without power to the EcoPort. Then they were shipped requiring the OEM cloud to be connected first before the EcoPort could work. And at the end of the day, this conformance testing with retail products, it's critical for utilities to know what they're getting. I'm going to stop there. Thank you.
Thanks so much, Tristan. Really appreciate it. Okay, yeah, so I will go ahead and switch it over. So Jackson, if you want to come on screen and then take control. Jackson, just making sure, are you on the call?
Yeah, hi. Hi, Noah, can you hear me?
I can indeed. Yeah, thanks so much. Just
Hi.
couldn't hear you before.
Great. Actually, I prefer if you take control because my Mac doesn't interact that well with Teams.
No problem at all. I just took control. And just let me know when you want me to switch slides, and
Okay.
I'll let you get to it.
Great. Okay, I think we'll hit the fast button because I think we're running out of time. Well, thanks again. I wanted to just echo all the sentiments regarding AWHI. I think it's been a fabulous forum in terms of sharing ideas and experiences. So I thought we've been at it quite a while. Some of the earlier water heater, for example, we actually worked with GE Geosprings back in the late 2000s. So we've had some experience in working with all sorts of different brands of water heaters over the years. Next slide, please. So there's basically 3 things I wanted to share today. One is to echo some of the things that Tristan has just shared. It turns out that every brand actually does comply to the standard a little bit differently. I'll give you some examples. For example, brand A may actually report energy used by their baseline, including the communication systems, and some do not. There have been instances where we have found that energy reported is not the same as what is separately metered. So there's some accuracy issues. And then there are times where when the resistive element kicks in and it still wasn't reported. So the difference in terms of the energy used could be substantially different than what the actual, which obviously will pose an issue. So one of the things that the standards needs to do going forward is to tighten up the specifications relative to what is being published in 2045. So that's one of the things. The other one is fairly recent, is that we found that some vendors that enable ALU or advanced load up, which is required, by the way, because some of the business cases to have these demand flexible load programs required a lot larger loads to make it viable, which I'll have some comments later on. But in activating ALU, some brands actually get into bouncing off the hysteresis, kind of like internal combustion engine running hitting against a red line. So it actually cycles too much, which caused some premature failures. So there are a lot of details. I won't have time to get into all of the things findings, but suffice to say that every brand and model have some slightly different response, even if it was trying to comply to the 2045-A or -B. Next slide, please. This is something that actually Jeff Wicks and I had talked about previously, and the last two slides are actually very similar. We need to go between pilot programs to a really meaningful numbers, and so one of the questions that Jeff had asked me, or we had discussed, is that what are some of the impediments to prevent that? And there are really several. One of them is institutional. And I would categorize it as alignment of incentives, because there are some inherent conflict of interest. What I mean by that is if there is a entity that wants to maximize revenue and profits, how the flex loads are implemented, or if it is even implemented, is an issue. And then there's another one, which I like to call the user information. In fact, last week in the IRAC meeting, Elizabeth Parks from Parks and Associates presented some information about consumer devices. And she was lamenting that for smart thermostat, a significant percentage is purposely unconnected because the users are not comfortable with having third parties having access to what's going on in their house, which is a significant impediment. So I would categorize this factor as device sovereignty, which in part is proportional to the central versus distributed computing. What I mean by that is that in order to optimize a water heater or an electric vehicle charging or a thermostat, having local knowledge of what the use profile, the user patterns are, is absolutely required for optimization. How that information is computed and if it needs to leave the premises is a major factor. So I think this is something that a lot of haven't been talked about a lot, but I believe this is a major impediment as presented by the likes of Parks Associated last week. So these are some of the challenges I think that policymakers are in a position to help mitigate. The other thing that I heard today is that, how do we make a market transformation? And one of the most powerful is to have market pull. Well, how do you generate market pull? Is to have product and services that people actually want and not try to shove it down their throats, because it really makes sense. So if we can go to the next slide, please. So how do we make these programs scale? This is from our perspective, and we've been at it, like I said, for a while now. And one of the things that we think is absolutely needed is to align the public policy so that the incentives are aligned, so that we, for example, I'm actually right now optimizing my heat pump water heater because it's in the warmer months now. So the output of the water heater for my house where I am right now is pumped into the HVAC system and distributed. So I actually have a load up even if the rates are actually high, because it's the water heater compressor is only 10% of what the air conditioning compressor is. If I can get by with circulating air and so on. So my point is that sometimes incentives need to be aligned with a more global optimization. And in the case where it may make sense for the various entities here to make sure that what we do collectively save individual consumer money, but at the same time defer capital expenditure for utilities, and we're looking to work with the public policy folks to make sure that these are aligned, because right now it's not well aligned from where we sit. For example, some of the rates in parts of the country are so high that it's actually inverted. Now, someone mentioned that for gas water heating, it actually in some cases less expensive than electricity, but it's actually the same case with some electric vehicles and their gas counterparts, which is frankly shocking. So I think there are some public policies relative to rates and how these things need to be aligned so that we can all get to a lower carbon system together. The next one I shared also with Jeff. Oh, no, sorry, go back. I need to hammer this one. The healthy supply chain is really important because without scale, companies like ours, and like I said, Tristan and I and others have talked about this, you know, we've been at it since the beginning, and the numbers that are in trying to support low pilot numbers with especially local manufacturing and so on, extremely difficult. So we need to have a path where we can get to meaningful scale, because without scale, you know, this is all the efforts are moot. We need to have scale in order to be meaningful for the various participants, but also from a societal standpoint, you can't move the needles with pilot numbers. It has to be full scale commercial numbers. And lastly, that we think putting together an entire system all along the supply chain, along with the policy, so that we have a killer product set of product and services, so that the consumer can see the value. And one of the things that we are advocating is the creation of more stringent metrics, just like the fact that technical metrics need to be tighter. So should we be optimizing towards more concise consumer metrics. Next slide, please. So one of the blogs that I had previously collaborated with others is published at SEPA. You can look for the consumer metrics, and it looks at not only cost but all sorts of other factors like reliability, aesthetics, and also Tristan touched upon this a little bit as well. And that we believe it's absolutely critical, and that is the ease of install and use. And you have to be successfully connected in order for any of these programs to take advantage of the real-time nature. So having a signal that's available, and in some cases we advocate a broadcast model in terms of a hybrid, so you have the best of both worlds. So subscription is a factor, along with attrition over time. The last
Jackson,
one
I'm just gonna give you a 1-minute warning here.
Sure, thank you.
Doing great though.
And the last one is privacy and security. As I said previously, if these systems, some folks are uncomfortable with the information going out. Last slide. This was actually previously shared. We didn't have a chance to talk about this today, but we had been involved with the AWHI on creating a cybersecurity framework to protect both the consumers along with the manufacturers. And I think Jeff will have a more update on this. And I'll ask add one last point. Today being June 6th, 80 years ago, as everybody knows, was D-Day. And to achieve something great, nations, not just companies, nations have to get together. And in the beaches of Normandy, there was 5 beaches. 2 was taken by the British, 1 Canadian, and 2 US. And I can tell you, in my house, we actually have a Normandy medal because my father-in-law served in the Royal Navy.
That's amazing. Thank you for sharing that anecdote. Well, thank you so much, Jackson, and totally agree with that sentiment that it's not just a U.S. problem we're trying to solve here, right? It's trying to slash global emissions, and hopefully the U.S. is a leader in that space, kind of aided by the work we're doing at AWHI. So with that, Lily, I'll let you take over. Would you like to take control, or would you like me to keep driving?
I think it's fine if you keep driving the slides, since we're short on time.
Perfect. All right. And yeah, feel free to not, rush super hard here, but 5-6 minutes is perfect.
Sounds good. Hi everyone. My name is Lily Buechler, and I'm a graduate student at Stanford, and my research has focused on developing predictive control strategies for residential water heaters to be able to respond to more dynamic price signals. And so today I was just going to highlight a couple of the main things that we've learned through our work on testing these strategies in a lab testbed, and kind of what additional testing and research may be needed in the future to make these strategies a reality. Next slide. So there has been growing interest in using more dynamic price signals to incentivize load shifting for flexible devices. In certain ways, time of use pricing can be pretty limited in its ability to incentivize load flexibility in that it doesn't represent real-time grid operating conditions. And depending on how it's designed, dynamic pricing can potentially be more effective at incentivizing useful load shifting on a 24/7 basis, which is important for renewable integration and decarbonization. And so to do this, devices need the control logic to translate those dynamic signals into control actions while making sure that consumers have enough hot water. Next slide. And so predictive control strategies basically provide the control logic for water heaters to automatically respond to prices. So basically these approaches calculate when a water heater should load up and by how much by solving an optimization problem, which tries to minimize costs based on forecasts of future prices and the use patterns of an individual consumer. And so that controller will receive price information from a price server. It uses a model of the water heater and information about how an individual consumer uses water. And so learning that consumer behavior is a really key part of these predictive control strategies. And there's different ways to do that. One option is to use a flow meter and directly measure those draws, but that isn't always practical or realistic in residential settings. But there are other approaches that involve using data from the water heater, like temperature measurements or tank energy values, to estimate those consumer use patterns and then use that information to make load shifting decisions. Next slide. So I just wanted to highlight a couple of the main things that we've learned through lab testing of these sorts of predictive control strategies over the last couple of years, and some areas that may still need research and testing in the future. So one key point that we found is that which variables a controller receives from the water heater and how those variables are calculated and measured affects control performance. So currently under CTA 2045, the water heater provides a single energy take value, which is a measure of the energy content of the tank. But how that value is calculated is generally up to the manufacturer. And as was mentioned previously, and there was a presentation on this at the Hot Water Forum a couple months ago, those values can sometimes be inaccurate, and those inaccuracies can affect controller performance. So in the future, it may be advisable to try to establish some consistency in how those variables are calculated across manufacturers and try to ensure some degree of accuracy. We've also found that controller performance in some circumstances can be improved pretty significantly if you have more detailed measurements from the tank than just a single energy take number. And having this more detailed state information can improve your ability to accurately estimate consumer use patterns. And so details on how these variables are calculated and measured do matter and are factors that should be considered when implementing these strategies. And then the second point here is that these predictive control strategies often need to be tailored to a specific water heater design. Controller design depends on whether a unit is a heat pump or if it's a resistive element, whether it has a thermostatic mixing valve. And heat pump water heaters can vary quite a bit in design between manufacturers. So I think there needs to be more lab testing and field testing of these strategies on a wide variety of different water heater models to validate their performance and to build some trust that these strategies do work. And then the third point here, one main challenge with predictive control strategies is that they are more complicated and computationally expensive than the simple rule-based control strategies that we typically use for time of use pricing. And because of that, maybe there are some questions about whether this control logic should sit locally or in the cloud. Through our work, we found that it's possible to implement these strategies on low-cost microcontrollers, and so it's possible to implement it locally and not rely as much on the cloud if you want to do that. But I think there's more discussions to be had about how these control architectures should be designed and kind of what should be done locally versus in the cloud. And I'll wrap up there.
Awesome. Thanks so much, Lily. And yeah, it's just great forward-looking stuff. Really appreciate your points, especially on like the computational space and potential testing to be done in the future. But yeah, thanks so much, y'all. Joe, I'm going to turn it back to you for the final slide here.
Oh, thanks. Thanks, Noah. Thanks, Lily, Tristan, and Jackson. Thanks to you all for sticking with us. This may become a 2-hour meeting. We've always got a lot to say. Um, really appreciate everyone being here and talking about where we've been in the last 5 years. We'll see you at the next one. Ralph, I'll leave you with the closing word.
Well, I have to say, Joe and everyone involved in AWHI, it's just been delightful to see the growth of the initiative. And we are so excited about the next 5 years. And I think, thinking about 5 years from now, we're on the cusp of 2030. So we have a large effort to bring about this market transformation. But I am very confident that in 5 years, we'll be celebrating that success. So thanks all. Thanks for joining and contributing. And so excited to get into the next 5 years. Take care.